Today we will see how to solve a linear programming problem involving two variables by using graphical methods. So this is the given linear programming problem in which we have to maximize the objective function z equal 4x plus 6y, which is subjected to two constraints x plus 2y less than equal to 8, 6x plus 4y less than equal to 24 with x and y greater than equal to 0. So we can see that there are two constraints 1 and 2. Let us give them equation number 1 and 2. Also there is a non-negative restriction which we represented by say equation number 3. So if we look at the steps, the first step says consider each inequality constraint as equation. So let us consider the constraint 1 as an equation. So if we write it as equation, it will be x plus 2y equal to 8, which is a linear equation in two variables x and y. Graphically, it represents a straight line. Now, second step says that plot each equation on the graph as each one geometrically represent a line. So we need to plot this line. So to plot any line, the easiest way is to find 2 points that satisfy this line and then join them. So to find those 2 points, what we'll do? We'll put each of the variable equal to 0 one by one. So for that, first let's put x equal to 0. So what it will give you? 0 plus 2y equal to 8. That gives you y equal to 4. So we'll get our first point 0, 4, because we know that always whenever we write a point, we write x coordinate first and then y coordinate. Okay. Now this is one point. To get the second point, what we'll put? We put the another decision variable y as 0. So what we get? X plus 2 times 0, that will give you 0 equal 8. So this gives you x equal 8. So what we'll get? The second point, x is 8, y is 0. Okay. So let us draw this. Okay, before drawing this, let us get the points for constraint 2 as well. So if we consider constraint 2, it is 6x plus 4y equal 24. Again, it represents a line and we need to get 2 points. So for that, we put x equals 0. That will give us 6 into 0, that is 0 plus 4y equal 24. That is y equal 6. So this will give us the point 0, 6. Similarly, we put y equal 0. So it is 6x plus 4 times 0, that is 0 equal 24. That gives you x equal 4. So this will give you the point 0, x is, what is x? X is 4. So the first coordinate is x. So 4, 0. Okay, we'll see that 0, 4, 8, 0. These are points are corresponding to constraint 1, while 0, 6 and 4, 0. These are the points corresponding to constraint 2. So let us now plot these points. For this, let us consider this as x-axis and y-axis. X-axis, this is our y-axis. 2. If we look at the scale, on x-axis, the maximum point we need is 8. On y-axis, we need up to 6. So we divide it in the scale of 2. 6, 8, and say 10. Similarly here, 2, 4, 6, 8, 10. Let us consider the constant 1 first. This 0, 4. x is 0 and y is 4. So it is this 4. Next is 8 comma 0. X is 8, y is 0. And we will join this line. This is corresponding to constant 1. Okay. Now if we look at this constant 1, it is inequality. It is a constant. X plus 2y less than or equal to 8. Equality means all the points on this line. Now we want less than. So it means we need to get the region where it is. So to get the region, that is to determine which side of this line, up or down, satisfy the feasible region. So for that, what we will do, we choose any point on either side of the line and check if it satisfies the constraint or not. So let us consider point here. This is point 0, 0. It lies on the left side of it. Let us see if it satisfies constraint 1 or not. 0, 0, it means x is 0 and y is also 0. So this will give you 0. Is it less than 8? Yes. So it means it satisfies the constant. This side of the line satisfies the constant 1. So it means the region will be below this line. The feasible region will be below this line. All points below the line. Okay. Now let us plot the second constant. It is having the points 0, 6. X is 0, y is 6. Other point is 4, 0. Let us join these 2 points by a line. So this is the line which is represented by, say, 2. Again we need to check which side of this line, either above or below, satisfy the constraint 2. So again on the left side 0, 0. This point lies below the line. So let us see if it satisfies this constraint 2 or not. So if we put here this 6 into 0 4 into 0, again this will give you 0. Is it less than 24? Yes, it satisfies the constraint. So it means all points below this line will satisfy the constraint 2. So this will be the feasible region. Now what else we have? We have the non-negativity restriction given by equation number 3. We have to check which is the region satisfying this. Now what 3 says? 3 says x greater than equal to 0. So if we consider the equation, consider it as equality, it gives you x equal to 0, which represent nothing but y-axis. So y-axis is nothing but here. This is x equal to 0. Now we want x should be greater than equal to 0. It means all the points towards right side of this y-axis are in the feasible region. Next is y greater than equal to 0. If we consider it as equation, it is y equal to 0. That is nothing but x-axis. X-axis, that is y equal to 0. And we need all points greater than equal to 0. It means all points above the x-axis satisfy the feasible region. Now we want to find the region which is satisfied by all the constraints 1, 2 and 3. So if we look at carefully, in this region bounded by this red line, we can see all the arrows are coming in. So this is our feasible region. Okay, is the region where we will get the solution. So the next point is to find the corner points. So the corner point is this one. We denote it by O, which is 0, 0. One corner point is this A. Its coordinate is x is 0, y is x is 4, y is 0. Another point is B, whose coordinates we don't know. Let us name this point as C, and its coordinate is 0, 4. Now our task is to find the coordinates of point B. If we look at this figure, this point B is the point of intersection of this green line, which is nothing but the equality of constant 2 with the intersection of this blue line, that is the equation 1. So to get the coordinates of point B, what we need to do? We need to solve the equation x plus 2y equal to 8 along with 6x plus 4y equal to 24 to get the values of x and y. Let us see how to solve it. Equation 1 is x plus 2y equal to 8. The second equation is 6x plus 4y equal to 24. So to solve this, what we will do, we will make coefficient of one of the variables same in both of the equation and then subtract them. So the easiest way, say here it is 2y, here it is 4y. So we multiply this equation by 2 so that it will become 4y. So what we'll get? 4x, not 4, sorry, 2 multiplied by x. So it will be 2x plus 2 into 2, 4y equal to 8 to the 16. Okay, and now we will subtract them. Minus, minus, minus. So what will we get? 4y with minus 4y cancel. 6 minus 2, it is 4x equal 24 minus 16 gives you 8. So this gives you value of x as 2. Now to get the value of y, we substitute this value of x in any one of the equations. So for simplicity, let us put in the first one. So what we'll get? 2 plus 2y equal 8. So this gives 2y equal 6. That is y equal 3. So now we have the value of x as well as y, which is nothing but the coordinates of point B, that is 2, 3. So up to point 3 we finished. We got the all 4 corner points. The next step is compute the value of objective function z at each of the corner point. So for that, let us prepare a table. In this table we have 4 corner points. So we write here points and here the value of z. Okay. So the points are O, which is represented by 0, 0. Next point is A, which is 4, 0. Next point, if we see B, that is 2, 3. 2, 3. Let us extend this table. And point C, which is 0, 4. 0, 4. Now at each of this point we need to get the value of z. So z we will get from our quotient, which is nothing but we need to maximize z, which is 4x plus 6y. So we write it here, z equal 4x plus 6y. And remember what we have to do, we have to maximize it. Okay, so we'll calculate the value of z at each of these points one by one. Let's consider the first one, z equal. We put both x and y 0. So what we will get? 4 times 0, 6 times 0. So we'll get 0. This is the value of z at point O. that is 0,